Okay, hello everyone, welcome. Can you hear me? Can you hear me? Okay, thank you. Okay, so hope all are you already get all of recorded video class for the first days and also get all of practice code. So basically today is our second days online training program on Google Earth Engine. So first of all, I will try to discuss about that course content for the second days. Then we try to move our second days class. Let me open my course syllabus. So basically today's session we discuss about that how we can easily filtering and displaying the satellite images, mainly Landsat, Sentinel or MODIS, this type of satellite imagery, how we can easily filter and displaying in Google Earth Engine, as well as how we can easily create the satellite composite. Okay, so basically median composite or mosaic composite or mean composite. So this type of composite, how we can easily create, we also discuss about that. And we talk about the band combination, so how we can easily create different types of band combination, such as true color band combination, false color band combination, or any other band combination, how we can easily create, we also discuss. And how to export the satellite imagery, basically Landsat, Sentinel or MODIS. So this type of satellite imagery, how we can easily export, we also discuss. And also talk about that import, filter, reduce, clip and display the raster data in Google Earth Engine. We talk about the time series analysis, how we can easily create the time series analysis and also export any shapefile from Google Earth Engine, and also talk about the annual image composite using Google Earth Engine. So let us go. We try to discuss all of things step by step. I hope you can easily get that all of things very properly. So let me open my slide. So we already know about that Google Earth Engine is a totally cloud-based platform. Okay. And when you're using the Google Earth Engine, you don't need to download any kinds of satellite imagery, because we can easily access all of satellite imagery from Earth Engine public data catalog. Okay. So basically Earth Engine public data catalog stored different types of satellite imagery. Okay, so when you're using the Google Earth Engine, you don't need to download any types of satellite imagery. All of satellite imagery we can easily access from Earth Engine public data catalog. We can easily access. It can be Landsat, it can be Sentinel, it can be MODIS, it can be train or land cover data or atmospheric data. So all of satellite imagery we can easily access from Earth Engine public data catalog. So this is the great opportunity to use the Google Earth Engine. We don't need to download any kinds of satellite imagery. We can easily access all of satellite imagery from Google Earth Engine data catalog. And this data catalog is stored more than 200 public dataset. We can easily find out more than 200. And we find out that more than 4,000 new images every single day we find out from this data catalog. More than 5 million images we can easily get from this public data catalog. We also get that more than 5 petabytes of data from this data catalog. And this is the link Earth Engine data catalog. So this is the main website for Earth Engine public data catalog. Or if you want, you can simply go to the code editor. Just simply go to the link, then you can easily find out the code editor. So from this code editor, you can simply search here. You can click on here on the search, and you can see the browse data catalog. Click on here the browse data catalog. So then we can easily get all of it. This is the Earth Engine data catalog page. So you can check here all of data, surface temperature data, or climate, different types of climate data, then atmospheric data or weather data, so precipitation, rainfall, tropical rainfall. So different types of data we can easily find out. Also you can see the imagery, basically satellite imagery. It can be Landsat, Sentinel, or MODIS. Okay, as well as we also get some high resolution imagery. Okay, so it's not available for that all region. For some specific region we find out this type of high spectral satellite imagery, but it's not available for the globally. Okay, so further let's discuss about this type of high resolution imagery. Also you can see that this type of geophysical data, basically train data. We also find out the land cover data, different types of cropland or other geophysical data we can easily access from here. Not only for that, if you just click on the Landsat, so then we find out all of Landsat collection. Okay, so you can see now this is the collection 2, Landsat collection 2, the second major reprocessing effort on the Landsat archive. Okay, so this is the collection 2. We find out this type of data: Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. We can find out all of dataset for Landsat. Not only for that, click on the Sentinel. So then we find out all of Sentinel image collection. For the Sentinel 1, basically SAR data, we can easily find out. This is the Sentinel 2 multispectral instrument. Also you can see about that Sentinel 3 ocean and land color instrument. Sentinel 5P mainly tropospheric monitoring instrument. As well as we also get some derivative data set, such as this is the dynamic world land cover data, this is the ES world cover data. So it's a globally available, this type of data. Also you can see the cloud score, harmonized v1, Sentinel 2 cloud probability. So all of data we can easily access from here. Also click on the MODIS, then we can find out all of MODIS collection. Okay, different types of MODIS data for the different things. So now how I can work this type of dataset, how I can work with my code editor, I will try to explain about that. So let's go. Let me open my slide. So first of all, how we can easily filter and visualizing the satellite images in Google Earth Engine. So basically when you filter your satellite imagery, this filtering process is depends on some factor. First factor is your region of interest. So region of interest or area of interest is one kind of major factor for filtering. So suppose in this case I need this satellite image for the Dhaka city boundary. So this is one kind of factor for filtering. Second factor, it's called the image metadata or image properties. Suppose I need the image not more than 1% cloud cover. So it's one kind of image metadata or image properties. I need only for those images which image will be not more than 1% cloud cover. Then specific time period. Suppose I need this image in year of 2017. I need this image in year of 2017 month of January, or I need this image in year of 2017 or 2020 summer season, rainy season, or wet season. So when you filter your image collection, all time we need to filter according to three factors. First factors is that region of interest. Okay, first factor is region of interest. Basically where you need the image, where you need this image, this is the first factor. Second factor is that image metadata. Suppose you need this image, which image will be not more than 1% cloud cover. Third factor is a specific time period. Suppose I need this image in year of 2017 summer season, rainy season, or any specific time. So when you filter any satellite imagery in Google Earth Engine, we just follow these three factors. Okay, so where you need the image, how you need the image, and when you need the image. So where mainly your study area, how mainly image properties. Suppose I need this image less than 1% cloud cover. than when you need the image for a specific time period. So let's go. We try to do it practically. Then I will show you that how we can easily work this three factor. And further we try to filtering our satellite images. So if you check the different types of satellite imagery, we already checked. So this is the Landsat, this is the MODIS, this is the Sentinel. So this is the image collection. So different types of image collection. Landsat image collection, MODIS image collection, Sentinel image collection. Clicking on the Landsat, we find out that you can see Landsat 9 image collection, Landsat 8 image collection, Landsat 7 image collection. So basically it's different on the time period. Suppose Landsat 9 is available from 2021 to present time. Landsat 8 is available between this time. Landsat 7 is available between this time. But when you filtering, this process is the same. Landsat 9 filtering process, you can also apply for Landsat 8. Landsat 8 filtering process, you can also apply for Landsat 7. Landsat 7 filtering process, you can also apply for Landsat 5, 4, and 1 to 5. So basically, the image filtering process is the same. Any kinds of image collection. We already know about that. Image collection is one kind of data types in Earth Engine platform. So this is the image collection. Image collection. Basically, it's one kind of data type. It's one kind of data types. Data types in Earth Engine. So it's one kind of data type in Earth Engine. So image collection. So now when you work with image collection, we need to apply some function. Okay. So for that, you simply go to the docs tab and you find out the image collection. Here you can see you find out that it's a feature collection, then image collection. You can see image collection. Okay. So this is the image collection. So if I just click on here, I find out all of image collection function. Here you can see. So all of function I can easily apply in the image collection. Okay, this type of function we can easily apply in the image collection. Okay, so you can see there's a lot of function only for the image collection. So this type of function we can only work for the image collection. Okay, so this type of function you cannot work with the image. Okay, this you can see also image. So this is the image function. So this type of function is only work for the image, not image collection. Also you can see e.geometry. So this type of function is only work for geometry. Also you can see e.feature collection. So this function is only work for feature collection. So this type of function you cannot use the feature, because feature have another function. You can see e.feature. So this type of function is only work for the feature. So now we work with the image collection. Okay, so if you just check the image collection, suppose Landsat, suppose I want to work for Landsat 9, just click on the Landsat 9. So now I find out all of information about the Landsat.
Excuse me,
Yeah, please, any question,
but
please.
there is no apparent picture and I have no problem.
Okay, just a minute. Uh, okay, now it's okay. Yeah.
Okay.
Okay. So let's continue. Yeah. Okay, so here you can see this is the image collection. Basically, image collection is the data types in Earth Engine. We can easily use it. So we can easily find out, you can see the e.image collection. So all of function, this type of function, we can only work for the image collection. Okay, this type of function we can only work for the image collection. Also you can see e.image. So this type of function we can only work for the image. Okay, also e.pitch geometry. So this type of function is only work for the geometry. So in this case we work with the image collection. So you can easily find out the Landsat. Suppose I want to work for the Landsat 9 image collection. So we find out this type of sensor reflectance. You can see it's a surface reflectance, then top of atmosphere. Okay, so basically surface reflectance we are used for LST monitoring or land surface temperature monitoring or land use land cover mapping, and top of atmosphere basically it is useful for monitoring the different types of indices such as NDVI, NWI, or this type of things. Suppose I want to work for top of atmosphere, just click on here. So now I find out here, you can see this is the USGS Landsat 9 collection 2 tier 1 top of atmospheric reflectance, and this data set is availability between this time period, we can easily find out. And this is the dataset provider. The dataset provider mainly USGS and Google. And if you check, we find out this is the Earth Engine snippet. Okay, so this is the unique ID about this dataset. So basically this is the directory. Okay, this directory stored this Landsat 9 top of atmospheric reflectance collection 2. So you can see it show the Landsat, then it show about the Landsat 9 collection 2 tier 1 top of atmospheric reflectance TOA. So this is the snippet ID, or this is the link. This is the link. This data, all of data for Landsat 9 top of atmospheric reflectance is stored in this link, or in this snippet it is stored. So now I need to import this data. I need to import in this code editor. So how I can import? So very easy. Just copy this ID. Just copy and then paste here. So now it now take a variable. We already know about that, how we can easily take a variable in the JavaScript. Previous class we already discussed about that. For the JavaScript, when you take the variable, just use a var keyword, then put the variable name. And variable name can be anything. You can put any name as a variable. Suppose I put the name L9. Okay, so this name you can put any name as a variable. So now this is my collection. This is my full image collection for Landsat 9 collection 2 tier 1 top of atmospheric reflectance. So this full image collection is stored in this variable L9. Okay, so now I want to check how much images are available in this collection. In this collection, how much image is available, I want to check it. So for that, just print this L9 and use the size function and then run the code. So now you can see it's computing this result, how much images are available in this collection. So basically this full collection is stored in this variable L9. So L9 is stored all of image collection. We find out, you can see this is the total image collection. This is the total image collection. It's available in this variable. So suppose these things I want to work with Python. So how I can work with the Python? Basically in this online training program, I will teach you Python and JavaScript at the same time. So that's why you can easily learn Python and JavaScript easily at the same time. So let's go. We try to create the environment for the Python. Just open the Google Colab and welcome to Colab. Just click on here. And then I just open my for previous days code, which I already make the environment of Google Earth Engine for Python API. So in this case, just I simply run it again. Okay, suppose I just import GE map. So now it importing the GE map. Then import Earth Engine. Then authenticate, mainly just connecting with your email address, which email you already used to make the Google Earth Engine account. Just I use this email. Then continue, and then continue. Then you have to put the initialize and also put the cloud project. So I already did. Just I run the code. It also okay. So now it's ready to use the Google Earth Engine code editor. So let's go. I just write the code in here, new cell. So this image collection I need to import in the Python. So how I can do it? Just copy the same code. Just copy and further paste here. We already know about that. For the Python, we don't need to use the var keyword. Just I remove it. Just I remove. Okay. And then if I just run the code, we find out this type of result. Here you can see it show this type of result. So now how I can do for more better result? So for that, just remove the print. It's not need. Only call this variable name. Only call this L9. Basically, it store it the full image collection, and then put here the get info function. Okay, then run it. So now it's computing all of images. So we find out this type of problem. Here you can see it show that collection query abroad after accumulating over 5,000 element. So let's go. We just try to check for size. So put here the size function. Size function, basically it's computing the total size, and then I put here the get info, and then just run it. So you can see, find out the same number. So this is the total image collection. This is the total image collection. It is stored in this variable L9. Okay, so this is the total image collection for Landsat 9. Top of atmospheric reflectance is available. Okay, we also get the same result also in here. So this image collection is available between this time period 2021 to 2025. So between this time period, we find out the total image collection. This image collection, this is my image collection. So this image collection I need to filter. So how I can filter? So for filtering, we just need to apply this three factor. First factor is your region of interest, your area, your boundary. So which area you want to need this satellite imagery. Second factor is image properties. Third factor is specific time period. So we find out this is the total number of image collection, and it's for the whole world globally. But I don't need for the global. I just need only for the specific boundary. Suppose I need it for Dhaka city boundary. I need it for a specific polygon or a specific point. So let's go. We are simply importing just our study area. Previous class we already know about that, how we can easily import our study area. Suppose I just simply import a study area of Dhaka city boundary. Suppose, okay, this is the study area, just I import. Okay, so this large number of image collection is available for the whole world, but I don't need for the whole world. I need only for this boundary, basically Dhaka city boundary. I need the image. So here you can see this is boundary. I need the image only for this boundary. So just I import, we find out the table. It's a default variable name. You can put any name as a variable. I put the name, suppose RY. Okay. So now how I can filter this study area? So for that you can check it, click on the image collection, and you can easily find out a function. It's called the filter bounds function. You can see. So this is the filter bounds function, and this is the geometry. It's the argument, and how it will work. So basically shortcut to filter a collection by intersection with geometry. So in this case, Dhaka city, this is my geometry, and I want to shortcut to filter a collection because I have a collection. So this collection I want to filter by intersection with my study area of Dhaka city boundary. So for that I need to use the filter bounds function. Okay, so let's go. We try to use it, filter bounds function. So for that, just take a variable. You can put any name as a variable. I put the name, suppose filter region, and this image collection is stored in a variable. What's the variable name? L9. Just I copy and paste. Okay, and then we have to use the function filter bounds, this function, because I have a collection L9. It's stored total this collection. This collection is stored in this variable. So now I want to filter intersection with my study area. So for that I need to use the filter bounds function. So just I put here the filter bounds. And what is the argument? Argument is the geometry. And what is the geometry? Geometry basically feature collection or geometry or area, okay, basically polygon. So in this case I want to use the Dhaka city boundary, and Dhaka city boundary is stored in this variable ROI. So just write here ROI. So now this variable is stored only for those images which images are available in my region of interest. So let's go try to check it. So for that, just take a variable, suppose print, and call the filter region and use the size function. Run the code. So now it computing, we find out the 129 images are available in my study area. Okay, in my study area in the Dhaka city boundary, we find out total 129 images. So this code I want to apply in the Python. Just copy and go to your Python code, just paste here. So in this case you can see ROI, I need the ROI. So just I also call the ROI. So we already import the ROI in here, just copy and copy this ROI. Just I copy these things because it is stored in my shape file, and I want to just take the new cell in here and paste. And we already know about that var is not need, because it's a Python, var is not need, just run it. Okay, and also this var is not need, just I remove, because Python we are just define the variable. And then print is also not need, just I remove. I just put here the size mainly computing how much number. From here I can get the information, mainly get info, it provide the information. So now run it. So we find out the 129. Okay, so for my study area in Dhaka city boundary, I find out 129 images. But I want to apply the another factor. So what is the another factor? Suppose I want to filtering image metadata. I need only for those images which image will be not more than 1% cloud cover. Okay, suppose from this 129 images, I need only for those images which image will be not more than 1% cloud cover. So I want to filter the image metadata. So for that, you can simply take the another function. You can see the filter metadata. So this is the filter metadata function. So basically shortcut a filter a collection by metadata. Suppose I have total 129 image collection. This 129 image collection I want to filter. From 129 image collection, I need only for those images which image will be not more than 1% cloud covered. So for that I need to use the filter metadata function. So let's go, we try to use it. Just I copy this function and I take a variable, suppose filter metadata, and call the filter region. Okay, because this variable is stored at 129. I want to need from 129 images only for those images which image will be not more than 1% cloud cover. Just I copy and paste here. Just I copy the variable name because this variable is stored the 129 images, and apply the function filter metadata and call the image property. You can see first argument is the name. Okay, name mainly image properties name. You can see name, the name is that collection instance. We find out that name is the property. Okay, so you can easily find out that image properties. You can see the image properties. So you can see the cloud cover or cloud cover land. You can also filtering the collection category, tier 1 or tier 2, mainly tier of scene. Also you can see the collection number. Okay, so I want to choose suppose cloud cover. I want to choose cloud cover less than 1% images I want to need. So for that, just I paste here and then put the operator. You can see second argument is the operator. So what is the operator? Operator, it can be, you can see equals, less than, greater than, not equals, not less than, not greater than, start with, ends with, not starts with. Okay, this type of operator. In this case I want to choose less than, so just put here the less than and set the value many number, value is the number. Suppose I put the 1. So now what happened? So it's my collection filter region. This filter region have total 129 image collection. From 129 image collection, I just choose only for those images which image will be not more than 1% cloud cover. So now let's check how much image less than 1% cloud cover. Print and filter metadata. Just copy and use at the size function. So it's computing how much images in a collection. It's computing. Let's go. We try to check it. We find out the 27 images. We find out the 27 images is less than 1% cloud cover. We find out. The same code you can also use in the Python. Just copy and then take the new cell and paste here. So we already know about that. Var is not need, just I remove. And then print is not need, just I remove. I put the size and get info function. Size and also put here the get info. So now run the code. We find out the 27. Same number of image collection, we find out 27. Okay. So this is the another factor we try to apply in here. So basically image metadata. I take the less than 1% cloud cover. Sometime you can find out the 0. Suppose for your study area there is no image. Then we find out it show the 0 value. When I find out the 0 value, it means that less than 1% image is not available for my study area. Then you just simply increase the value. You try to check, suppose less than 5%, less than 10%. Okay, then run the code, then we can also find out the value. So if when just suppose you put the 1% and you find out the 0 value, it means that less than 1% image is not available for your study area. Okay, so then you just simply increase the value, then we can also find out the image array. Okay, so now we apply the third factor for a specific time period. Suppose in this case, this image collection 27, what is the time duration? This time duration is that from 2021 to 2025, between this time period. But I want to work only for year of 2025. Okay, I need the image in year of 2025. So for that, I need to filter this 27 image collection, and we have to use this filter date function. Okay, filter date. So here you can see it's a filter collection by a date range. So you can put the date range, start date and end date, and filter your time period. So let's go, we try to do it. Just take a variable, suppose filter date. So this 27 image collection is stored in a variable. What's the variable name? Filter metadata. Just copy and paste here, and then use the function filter date function, and then put the time. Suppose year of 2025, 1st January, from year of 2025. What is the last time period? You can see that 2102. So just I put here that 02 21. So now let's check how much images are available between this time period. So just print this filter date and use at the size function and run it. So we find out the only for the 2 images. Okay, this 2 images is available between this time period, basically January to February, between this time period. So you can easily filter your own time period. Sometime you need the image for summer season or rainy season or any specific time period. So let's go try to apply it for the Python. Just a copy and then take the new cell and paste here. So just remove the var keyword and also remove the print function. Use at the get info and run it. We find out the proof. Okay, so okay, so now I want to check the more information about these 2 images. So how I can check it? So for that, just use the print function and call the filter date and run it. So now we find out that information about these two images. Click on here, you can see we find out that feature, basically two images we find out. So you can see the property, so you find out, you can see this is the cloud cover 0.02. Also you find out the image acquisition time. Okay, so yeah, this is the image acquisition time period. Okay, mainly 16 February 2025 we find out. And another image, just click on here and check the property. So you find out, you can see this is the image acquisition time. So same time we find out this tire, tire 1 and tire 2 we find out. So this is the collection tire 1, you can see tire 1, and also you can see second one is that tire 2. Collection number 2 we can see about that. So we find out this type of information from here. This type of information you also get for the Python. So just call this filter get and run it, and put here the get info and run it. So you can see find out this type of information also in here. Okay, we find out that all of band which are available in here. Also find out all of information for these two satellite imagery, mainly two scenes we find out in here. Okay, so let's go, we try to display, suppose this type of image I want to display in our map. So here you can see this is the first image and this is the second image we find out. So how I can display this type of single tiles or single image. So for that, just copy the ID. So you can see this is the ID. Okay, this is the ID. Just copy this ID and take a variable, suppose image. You can put any name as a variable and put here ee dot image and paste this ID. Okay, so now this image we simply store it in this variable image. Just we try to add a layer. So for that, just use a function map dot add layer and call the image and run it. So now it's add layer but not focus. For focusing we are just use here map dot center object. I want to focus my study area, basically ROI. So just put here ROI, zoom level suppose 10 and click to run. So now we find out this type of imagery, you can see it show as a tiles. Okay, so further we also try to add the band combination, then we also find out the different types of visualization, so it work as a tiles. Okay, so let's go try to apply it in the Python. Just I copy and paste here. So just remove the var and then also use here the variable name map. So just run the code. So we find out map is not defined because we just need to run the code. Suppose ge map, we find out in here. Okay, this code I simply run it. Okay, so now we can easily find out the map. So let's go, we try to add it again. Just run again. So now we find out this type of tiles here. You can see in the Python we can also find out this type of tiles. Okay, same result also find out here. So now you can easily add different types of band combination, but this image I need for my boundary. Okay, so this boundary, just apply the clip function, put here the dot clip with your study area, basically your shape file. So this is the ROI, it is study your shape file. So put here ROI, just run the code. So now you find out this type of result here, you can see. Okay, but it not fully fill up your study area. We find out some part is the missing and missing. So if you check it, suppose just add a layer, map dot add layer of your study area. Suppose map dot add layer of your study area, which is RY, and run it. So then it will look more better. Okay, some part are missing because these tiles is not fully overlay with my study area. I can see. You can see this part is missing. Okay, so this is my study area, so this part is not covered, these tiles. So now let me check for another image what happened. Another image, basically second image, this id I just copy and then just change it, just paste here and click run. So now let's check what happened. Okay, so now this tiles is fully fill up, you can see it's fully fill up. And further we also add here the band combination. Suppose for the band combination, just click on this, click on here, basically 3 band make a one combination. So we can easily choose our band combination, suppose b4 red, then put at the green and blue. Okay, so basically red, green and blue, it's called the RGB, or it also called about the true color composite. Okay, and then also stressing, basically it's one kind of data visualization process. So in this case we are using the different types of stress level to enhance our data and it look more better visualization. So I choose suppose 98% stressing level. So now it automatically show the range mean and max value. Just I apply. So now we find out this type of satellite imagery. Okay, we can find out this type of satellite imagery. Just import. Okay, you can see when I click on the import, a new line of code will be added. Okay, just copy the variable name and this variable name just paste after the object name. Okay, just after the image I just paste here. So now this visualization is setted with my map. Okay, when I do it, just it's setted. And you can also put the layer name. You can see it show about the layer 1. So I put it, it's a true color image or natural color, we can say. So now run the code. So we find out this type of things. This is the image. Okay, so this image, suppose you want to also apply for the Python. Okay, just let me copy the same code. Now var is not need, just I remove. Okay, just I clip with my study area. Okay, just I put the empty visualization and then run it. So okay, it create the 2 layer. So this is the image we find out. So further if you want, you can also add the band combination. Just click on the, you can see setting button and you add here, suppose you can see red, then green and blue, stressing suppose 90%, and then apply. So now you find out this type of satellite imagery. Not only for that, suppose I want to apply for near infrared, then red and blue, and apply. So now you find out this type of band combination. So you can easily use different types of band combination, because we are using the different types of band combination to identify different types of feature from satellite imagery. Or put here suppose short wave infrared one, then near infrared and blue, apply. So now we find out that this type of band combination. So we can use here the different types of band combination, also visualize the different types of images band combination to find out. Okay, you can also do it for in here also, just simply click on here and change it. So this is the process for the single image. Okay, so in this case we are just take the single image and make this type of analysis. But sometime we also need for median composite, we need the composite. Suppose all of image, just I make a composite. It can be mosaic composite or it can be median composite. For the different time we have to use it. Okay, so in this case, this is the process for the single date imagery. Suppose this image acquisition time 2025 16 February, this image acquisition time. But sometime the single image or single tiles is not cover your study area. Suppose when you work for the full study of Bangladesh, then you find out lot of tiles at the same time. Suppose if you simply search on the Google, suppose so you can easily click on here image, then also find out. So you can see. So for the Bangladesh, okay, let me just open it. So you can see find out the different types of tiles for the different part of Bangladesh. So when you work with a big study area, then we need to combine. Then we need to make the composite. Okay, for the different tiles. Okay. So in this case here you can see we find out this type of tiles for the Bangladesh. Okay, this is the path and row for these tiles, and we find out this type of imagery. So when you work with big study area, then we need to use the composite, because a small study area we can easily cover. A small study area we can easily cover for the single date imagery. But when you work for the big study area, then it will be not cover. Then we need to apply the image composite. Suppose I want to work for Bangladesh boundary. So just I simply import this Bangladesh boundary, and now if I just change my ROI, just I remove the previous ROI, and just I put the variable name as a ROI, and now click to the run. Now you can see what happened. So we find out, you can see this is the tiles. Okay, we find out this is the tiles, but other part of Bangladesh is not covered. So now how I can cover? So now we are just applying the composite. Okay, then we can easily find out that whole country boundary of Bangladesh. So let's go try to apply the composite. So you can see it show the total 22 images. Okay, we find out the 22 images, and all of images information you can also find out in here. You can see from the feature. Okay, these 22 images successfully cover for the whole country boundary of Bangladesh. And now I want to use all of images and make the median composite. Okay, then it will be fully covered. So let's go try to do it, how we can work with that. So just I simply comment this thing, just I comment I want to create the median composite. So for that, just I take a variable. Suppose I put the variable name is that median composite, and then you can see here 22 images. Okay, this 22 image is stored in this filter date variable. So I want to use all of images and create the median composite. So now if I just add a layer and call the variable name median composite and run it, so it show one kinds of problem. Let me check. Okay, just apply the clip function, clip with the study area RY. Okay, I hope it will be added. It show that layer error description length exceeds the maximum. Okay, so let me try with Python, then what happened. Okay, suppose just I change the study area. Let me change this RY and now try to work. Okay, it takes a lot of time. I think some will also issue for Google Earth Engine. So let me change the runtime. Click on the settings. Okay, let me try again. Okay, it take a lot of time. Okay, let me try to for a small study area. And remove the previous RY and put it's a RY. Okay, so we find out the zero because it show that less than 1% image is not available. So let me try to increase it, suppose 10%. So now we find out this type of imagery, but it is still also some place is not work. It means that for this type of place there is no image less than 10%. So just increase this. Suppose I put 20. So now it's fully fill up. We find out. Okay. So let's create that less than 20%, and we also find out it's also we create the median composite. And further, if you want, you can simply just display this imagery. Suppose red, green, and blue, and its stress is of 98%. And apply. So now we can find out this type of imagery, but in this case we find out this type of cloud. Here you can see this white pixel, it's indicating about the cloud, but this type of cloud we can easily remove using Google Earth engine. So these things I will try to explain about that how we can easily remove an cloud. For that our further class, okay, basically it discuss about that fourth number day how to remove cloud and haze from the satellite imagery. We also discuss in the fourth number class. Okay, so this is the process to work with median composite. So basically it's not a single image, it create the median composite from total 6 images. Okay, from 6 images it create the median composite, and you can get all of 6 images information. Basically this the total 6 images, we can easily find out all of information such as cloud cover. You can see also see about that image acquisition time. So all of information you also get from here easily. Okay, I think for the big study area, it creates some problem when you work with. So further, also try to check the solution and try to also explain about that. Okay, so when it will be big study area, it gets some problem now, but we can easily work with for the small study area. So further, I also try to show you that how we can easily work with the big study area. Okay, and also find out the solution. Or if just I open the coastal shape area and remove the previous RY, and I put the variable name as a ROI. So let's go try to check the result for that. Yes, we can find out the full coastal land shapefile. Okay, so further you can just click on here and add the band combination. Suppose I put here short wave infrared 2, near infrared and blue, stressing 98%, and then apply. Then apply. So now you can easily find out this type of band combination for this type of study area easily. Okay, so this is the process to create the median composite as well as also create the single date imagery. So further we also use this type of single date imagery or median imagery for the different types of remote sensing work. Okay, so any question about this topic, you can ask me please. Any question or any confusion? For filtering and displaying the satellite images. Okay, any question? Okay, I hope there is no question. So I also send you this type of code. You also try to practice for your own study area. Further, if there's any problem, then also inform me. Then I'll also try to guide you how we can work with that. Okay, so now we already write lot of code for displaying this type of satellite imagery and visualization. But in Google Earth Engine, we can easily shorten this type of code. Okay, in this case you can see for filter bounds I take a new variable, then filter metadata I also take the another variable, then filter date I take the another variable. But if you want, you can take only for the one variable and write all of function one by one. So these things is also possible. So let's go, I try to show you that how we can easily work with that. Just I comment all of those, just simply select and then control and forward slash. So now I just take only for the one variable. Suppose I put the variable name is that L9 and I add all of function one by one. So for that, just use here the dot notation and put here suppose filter bounds function, filter bounds with RY, then put here the filter metadata. I put here suppose cloud cover, less than suppose 20, and then put the filter date. I put the date suppose year of 2025, 1st January, from year of 2025 February 21. You can put any time period. So now I want to check how much image is available. So I just use at the filter, just call the variable name and use the size function. So now it's computing how much image is available after applying this type of filter bounds, filter metadata, and filter date. We found out the 26 images for my study area. So now I want to use all of images and create the median composite. Just use at the median. So now when I apply the median, you can see it create a problem. It show that this type of problem, we find out size is not a function. Okay, it means that size is only work for collection. Okay, size is only work for collection. Okay, but when I apply the median, then this variable stored the single median composite. Okay, just it work as a single image. So that's why it show this type of problem. Size is not a function. Okay, because size is only work for collection mainly more than one image. More than one image called as a collection. But when I apply the median, then it work as a single median composite image. So that's why it show this type of problem. Okay, so now size is not work because it's a median. So just I print only for this L9 and run. So you can see it's a image, not image collection. Okay, it's just a image. You can also use another function, it's called that type of function. You can also use, it's object. Okay, single object we find out in here. So now it's a object or single median image, so that's why size function is not work. And then just simply use the cliff function with your study area, which is RY. So now we can easily display. Just use our map.add layer and call the L9 and just run the code. So now we can easily find out this satellite imagery for our study area. So now you can see I just take only for this code and we can easily work with that. So for the filter bounds, basically where you need the image, your study area, then how you need the image. So in this case, for my study area, between this time period, less than 20% is available. I put the 20%. Then put here when you need the image. Okay, so basically where, how, and when. Just use these three things and we can easily filter. So after filtering, we can create the median composite and then set with our study area. So now you can easily find out this type of imagery. So these same things you can also work with Python. Just I copy all of code together and then call the Python. So you can see warning. So it's some problem. Okay, I think some networking issue or some things. So that's why now for the big study we face this type of problem. Okay, so let me try to fix later. Just I paste. And for this sample, we need to use here the hash for comment. So this is the symbol of comment. Okay, so also remove the var keyword. So now this full things just use a bracket and also close this bracket. Let's just run it now. Just run it. Alright, so let me change the study area, basically shape file. These things I want to change. Just I copy this RY and change it. And now run. So now it's also okay. You can see, just add the layer. And also map dot. So now run the code, we can easily find out this. Okay, it loaded. So far they can easily add the band combination. Click on here. Suppose I put at that near infrared, then red and blue is tracing 98% and apply. So now you find out this type of band combination. Okay, and we can also use it for the different types of remote sensing work. So this is the process to visualize and filtering this type of satellite imagery. Okay, for the first time I try to explain all of code, so that's why I elaborate this type of things. But when you write the code, just use only for this code, then it will be okay. There is no problem. Okay, any question? Okay, if there's no question, so move to the next part. Okay, so let's go try to discuss about that another data set. Click on the modis. So here we find out all of modis data. So using this process, suppose this type of process you also apply for other Landsat collection. Okay, so you also try to filter for Landsat 8, Landsat 7, or Landsat 5, Landsat 4. So this type of satellite imagery, you also try to filter for your own study area. Okay, and further face any problem, then also show me the problem. Then I also guide you how we can easily fix the problem. So let's go to discuss about the another collection for modis. So basically find out the lot of modis product for daily or monthly or 8 days. So different types of modis product we can easily find out. You can see the Terra vegetation continuous field yearly global 250-meter Terra land watermarks derived. Also you can see the modis land use land cover data. Okay. Also you can see the modis cover dynamics yearly global data. Modis deep area index data. Okay, surface radiation daily 3 hours data. So there are the lot of data we can easily access from the modis globally. So this type of data you can see, this is the optical land aerosol optical data. We also find out, okay, it provides a lot of data, so we can easily find out in here. So you can see the vegetation indices monthly, crab vegetation index is 16-day global. So you also try to read this type of data description, then you can get the more better idea. So now suppose one data, suppose I want to use this data and work with that. So this same process also apply for the others data also. Just click on here. So now you find out all of the information about this data. So basically it is the crab vegetation indices 16-day global 250-meter resolution. So this data, this is the dataset provider, and it's available from year of 2000 to 2025, and this is the ID. Okay, this is the unique ID. So basically this is the directory. Okay, from this directory you can easily access the data. So first of all, these things you need to apply. Just I copy, and then suppose just I paste in the Python, just paste here, then give a variable name. Okay, suppose I put the variable name is dataset. You can put any name. So now this is my image collection. This image collection, I just stored it in this variable, just on the code. Okay, there is no problem. And this data collection have a band. If you check it, this data collection basically it provides the two band, NDVI and EVI. NDVI mainly normalize difference vegetation index, and EVI mainly enhance vegetation index. I want to work for NDVI. Okay, so let's go try to do it. Just use a function dot select and select the NDVI. So now run the code. There is no problem. Okay, and this data set is available from time period. You can check 2000 to 2025. So you can simply choose a single time period or any time specific time period. So for that, use at the filter date function. Suppose I put this date 2025 1st January to February, and now run the code. So now we find out this type of information. I want to check how much images are available. So just use at the data set, use at the size function, and also apply the get info. Just run it. We find out the three images. Okay, so between this time we find out the three images between this time period. Okay, and it's globally we find out. So let's go try to display the map. So use your map dot add layer and then run the code. So now we find out the global NDVI map. You can see it shows this type of map. We find out it's available for the globally. Okay, we find out the globally NDVI map look like that, but I want to work only for the specific boundary. Or if you want, you also add the visualization. So let's go try to add the visualization, then it look more better. For the visualization, if you check the data set, they already provide some color code, this type of color code. Just I copy and I want to just paste here. So this is the color code they are using here default. So just remove the var keyword, it's not need. And the mean, just put here the quotation. Max, also put the quotation. Plated, also put the quotation. And just call this variable name and connect after the data set. Also put the layer name. Suppose I put it's a world NDVI. Just run the code. So now we find out this type of NDVI map for the globally. So we can easily identify what is the high vegetation, what is the low vegetation. We can easily identify this type of things. But this NDVI map, I don't need for the whole world. Okay, I need only for the specific country or only for the specific polygon. Okay, so that's how I can work with that. So just import your shape file. So if you want, you can also use this data. We already know about that. This data, US data. It's provide you international country boundary polygon. Or let me open a new code editor. So we'll search here US. So this is the data. I just click on here. So this data basically it provide you the international country boundary polygon. So just I copy this snippet ID for this data set, and I want to just import the data in here and give a variable name. I put the name, suppose it's a area. I'll put here ROI. Okay, so this ROI I want to filter. So just use here the dot filter and apply earth engine dot filter equal country name. I put the suppose Bangladesh. So now this RY, it stored the country boundary of Bangladesh. So just run it. Okay. And then if I just use here the clip function dot clip and put here the RY and run it, it show a problem. You can see this problem is that image collection object has no attribute clip. Okay. So it means that clip function is not work for the image collection. Okay. Because clip function is only work for the image. You can also check it. Suppose check the function of image. So this function we find out the clip. Okay. Clip function clip an image to a geometry or feature. So clip this function is only work for image, but in this case it's just a image collection. Okay, in image collection mainly three images, it's a total three images, so it's a image collection. So that's why it shows this type of problem. We find out this type of problem. So now these three images I need to use, and further I need to make the image. So now I need to reduce. Suppose you can calculate the average NDVI or maximum NDVI or minimum NDVI, and then you can easily calculate. So let's go try to calculate the average NDVI. So for that, I take a variable, suppose average NDVI, and they call the dataset and apply the mean. And further, when I apply the mean, then just use these three images and calculate the average pixel. Okay, and make a single image. So now I can easily apply the clip function, clip with study area RY. Okay, so just run it, and now I display the average NDVI. Just copy and paste. So just run it. So now you find out this type of NDVI map. Only for Bangladesh. Okay, so you can see you can get only for the Bangladesh. Okay, if you want, you can also add, click on here. You can also add the legend. You can see the legend. Just check mark and apply. So now it also added the legend of your map. Okay, so this indicating about the high NDVI, it's indicating about the low NDVI. Not only for that, any country you can put right here. So just put the country name. Suppose I need the result for country, for suppose Pakistan, just put here that and run it, and then just run it. We can easily get the result for Pakistan boundary. So now I can easily find out this type of anyway map, and you can also add the legend. Just click on here, and you can see the just check mark and apply. So now this legend is also added. Mhm. So now you can easily create this type of menu, or you can also import your study area and also work with that. Mhm. So these same things you can also apply for the Python, basically JavaScript API code editor. So for that, just apply the same process to work with that. Just copy this snippet ID and paste here. Then give a variable name. Suppose I put the name is that dataset, and this image collection have two band. I just select only for one band, suppose NDVI, and put here that filter date 2025 1st January from 2025 February 21, and then just check it how much image. Just use the print function and call the dataset, use here the size function. So now it's computing. We find out the three images. So now if you want, just add the layer, suppose map dot add layer, and call the dataset, run it. We can easily find out this type of NDVI map for the whole world. It visualize. Okay, you also add the color. So for the color, they already give you some demo color code. Just copy this demo color code and paste here, paste here. Just copy this variable name and add after. So now we can easily find out this type of color. Here you can see it show this type of color. We can easily identify what is the high NDVI, what is the low NDVI. We can easily get this idea from here. But when I apply, suppose for a study area, a specific boundary, suppose I take the data from here, and from here I just take the single country boundary, suppose RY, and this table I just filter. So previous days I also discussed about that, how we can easily work with this data set and filter the specific country. I put the same process. So filter earth engine dot filter dot equal, just apply here the country NA. I put the country name, suppose I need it for Bangladesh. So now further, if I just, you can see here, if I just use here the clip with ROI, it show a problem. We find out the same problem. It show that clip is not a function. Okay, so it means that clip is only work for the image, but I have total three images, so it's not the image, it's not a single image, it's just a collection. So this collection I need to reduce. So how I can reduce? I just apply here the mean function. So now it calculated the average pixel. Okay, if I run the code, you can see it shows this type of problem. So size is not a function, because size function is only work for the collection, but when I put the mean, then it stored the single average NDVI. So that's why size is not work. So then we are just applying that things. Just add a layer and clip with my study area. Just use at the clip with RY. So run the code. Okay, it also showing but not focus my study area. For focusing, just use your map dot center object. Object with RY. Oh my god. So now you can easily find out this type of NDVI map. Okay, we can find out this type of NDVI map or any country name. We can simply put in here. Suppose I need this result for Australia. So we can find out this is for Australia or any country boundary. Suppose I put here this Colombia. So I can easily get this type of country anywhere map easily. Okay. So this is the process, but this NDVI map have a problem. If you click on the Explore tab and click on this map, it show this type of long value. You can see we find out this type of long value. But we know that NDVI range, if I simply search here NDVI range, mainly -1 to +1. Okay, this is the range of NDVI. Always we find out it -1 to +1. But in this case, we find out the NDVI value, this type of lines value. So how I can rescale? How I can rescaling the NDVI value and get the range between -1 to +1. So for that, if you check it, they already provide some scale value. This is the scale value 0.001. So this scale value we need to multiply with your image. Then we can easily get this result. So before that, any question you can ask me, or any confusion you can also ask me. Any question? Okay, I hope there is no question. Okay, let's continue. Okay. So now how I can rescale this NDVI and get that result -1 to +1. So let's go to discuss about that. So for that we need to multiply. Okay, this value you can see a scale value. For rescaling, just use this scale value, just multiply with your all of images at the same time. Then we can easily get it the proper range of NDVI. Okay, so let's go try to do it. How we can easily do it.